Welcome to the new Cyber Frontier, bringing you the latest news and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's New Cyber Frontier.
Welcome to today's episode of New Cyber Frontier. On today, we're continuing our special series with the IEEE Blockchain initiative on blockchain for transactive energy. Today we have Dr. Claudio Lima, who is the chair of the standards group for blockchain, P2418.5. I've heard some other people talk about that. And the co-chair for the IEEE Blockchain in Energy initiative. Dr. Lima also runs his own company, the Blockchain Engineering Council. He's the co-founder. They do product engineering, proof of concepts, production-ready blockchain services, training, a lot of conferences. Many of you might have heard him speak, very kind of known around the world for being one of the top experts in blockchain. Welcome today. Thanks for joining, Dr. Lima.
Thank you, Chris. Appreciate it. Glad to be here.
Definitely. Kind of this version or this part of the series, this episode in the series, we're talking about standards. And there's no better person to bring on to talk about standards than Dr. Lima. But first, kind of in just opening up, tell everybody about yourself. How did you weren't always Dr. Lima, you weren't always the global chair for standards. Tell us about your background and your path to being where you're at.
Yeah, thank you, Chris. My background, I'm electrical electronic engineer from UK. I did my PhD in England, and I moved to California. I started up a new company there, spent 3 years, and then later I moved to Sprint Labs. So I spent almost my time at Sprint Advanced Technology Lab in California. And now I'm back in Texas, basically doing what we call digital transformation. It's everything that connects the dots, right? And I envision blockchain as a networking system. So having worked for Sprint designing complex network system, I realized that blockchain is more than a simple element. It is a networking system. And therefore, we are going to connect multiple elements, not only IoT, for instance, that collect data, but also machine learn that process and validate the data that blockchain can measure and modify and authenticate.
Yeah. So you've probably seen a lot in technology. If you look at kind of the progression over your career of watching technology, there's some key things that stand out. Where would you put blockchain in comparison to some other key things, maybe if you made a timeline?
Yeah, let's put it this way. So internet data is not trustable, right? So we are having all this fake news, and eventually deep fake is hitting the market with video, audio. So how can we create the provenance of that data? So how can we certify that data validation mechanism tracking who originated the data? So that's the problem the industry have today. So blockchain is that magical layer that fits and sits on top of the enterprise architecture that basically filter the noise, right? Basically show that, okay, this data is a valid data, it's a trustable data. I think I resume blockchain as a trustable database that is distributed, shared, and immutable.
Yeah. So if we look at that being a layer that sits on top of data, sits on top of companies, and we said, okay, maybe that's like a Facebook, right? It sits on top of the companies, sits on top of everything. We come to that, we go through that to get to our data. If a company like that would make a blockchain, say, oh, we're blockchain enabled, just trust us, is that different than having an actual, a transparency of blockchain? And what would the difference there be?
Yeah, that's different because we have different types of blockchains, right? So we have a public permissionless that you don't have authorization to join, like the Ethereum or Bitcoin. And you have the permissioner, that the one that's private enterprise consortium based, led by a company like Hyperledger and Corda. So these are more corporation 500 kind of consortium-based architecture, and it depends on the application. You can find ways to decide which technology you are looking for. But you are right. So blockchain has some tricks. I mean, you have to be basically the data you put in, the garbage in, garbage out. You have to make sure that data, wherever it originates, is trustable. And then you have to put also some validation at point of collection as well.
Yeah. Well, let's take a break. We're going to hear from our sponsors. We'll be right back in a minute.
Blockframe technology offers next-generation blockchain managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Welcome back to New Cyber Frontier. On today with Dr. Claudio Lima, and talking about standards in blockchain with this kind of continuation of the special editions and episodes for IEEE Blockchain, supporting that initiative. Dr. Lima, before the break, we were talking about, what is blockchain? Just that first thing, how it connects, it's that layer, but it can't be just some company tells you they're doing blockchain. It's the actual piece that you can verify. Tell us a little bit about that kind of trust you have in the verification piece that's needed.
Yeah, so I think the entire concept of blockchain is about the consensus, right? That is what we call consensus mechanism. That's an algorithm that is embedded into any blockchain system. So you have to reach consensus to get your data or transaction approved and put on the ledger. And once it's there, it's kind of immutable. You cannot change. Mm-hmm. There are some ways you can do, but most likely not. And the consensus is going to validate based on the peers, on the participants of the network that are authorized to handle that transaction. So consider blockchain as a distributed database, right? So anyone can have piece of that database. But in order for you to modify or change your information, all the members have to validate. And once they reach consensus, then you have the data printed or impressed or recorded in the blockchain.
Yeah, which is why standards is such a big piece and what you do.
Exactly.
So that's all the people, all the trust, all the different entities we're talking about roll into standards. Elaborate on what you do and what that is, and where the standards part plays in.
Yeah. So if you look at the history of blockchain, so back in 2018, so most of the concept of blockchain was about the cryptocurrency, Bitcoin, and ICOs and dApps, and so then we have a new field that emerged from that time, which is the enterprise blockchain. So basically, it's the permission and authorized kind of blockchain. And then if you look at most of the verticals in the industry today, the healthcare, the energy, so they are kind of they need to control the information somehow. But blockchain comes to help because they provide this extra decentralization. But how about if you take the benefit of blockchain decentralization plus the permission and our idea to control who enters, who does what with the information? So that's how we, back in 2018, we look at across the industry, there was no standard for blockchain. So we started doing the IEEE initiative. Under this initiative, we created a standard committee. So we're looking for promoting standardization. The first one was the IoT standard, and later we introduced the healthcare and the energy standard. Now we have dozens of standards running under the IEEE Standard Association.
Yeah, and you have a list of what those sections are. And I was looking at one of your slides here. Can you kind of go through those different areas?
Yeah. So basically, the one we are talking about here is the IEEE 2418.5. That's the energy standard. So the energy standard was created in, I think, October 2018 by GE, Siemens, ABB, and other entities like National Renewable Energy Labs. So we create that with the idea to define what blockchain is, number one, and then to define and promote in the energy space what the benefit of blockchain. Because so far, when you talk to executive utility company, they understand they think that blockchain is related to Bitcoin or cryptocurrency, which is not. We are trying to convey the message that blockchain is beyond that. It's more powerful than simple. I mean, it helps enable cryptocurrency and it helps in the fintech world, but also can provide value to other enterprises. And that therefore the 2418.5 was born with the intention to create a standardization process, or basically a layer that we can add to the smart grid architecture today.
Okay. And if you have a lot of different moving pieces with that, different task force, working groups, where is this at now? Kind of that big picture, all the moving pieces, or some of them you probably couldn't even, just explain them all, but.
Yeah. So we moved from entity to public base, membership base by January this year. This year, and then we got 300 members signing up. So it was amazing. So it's very difficult for the IEEE to have all this kind of interest. So right now we have active membership. We have monthly meetings, and then we have 4 task forces. One is the task force one, the cybersecurity. We are working on smart contract cybersecurity for the energy, and we just released a paper that 20 pages paper is going to give the direction in this field. We also have the use case task force. We are exploring different use cases in the energy and power industry. So, and there are 2 more. There is the smart contract task force. We are looking for ways to standardize the smart contract in the energy space. And finally, we have the interoperability task force. We have 4 task forces working with members, meeting regularly every week to come up with definition and the standardization of these ideas.
So how long, you have some deliverables here and there. So the paper you just said has just come out. What's the timeline, do you feel, that this becomes, I don't know, ever complete, but at least a viable energy platform usage set of standards?
Yeah, so writing and build the standard takes time because you have to get to the right momentum in the industry. Everybody understand the implication. And right now we are in the middle of that process. So we have created a solid draft. We have lots of content material. We plan to release the first editing that draft by February next year. So we are going to do some editings, and most likely we expect next year we'll release that standard. So it's been a long journey here, but eventually the team has done a great work. The members are experts in the field, and then we are moving forward with that.
Interesting thing, oftentimes standards and regulation requirements get, kind of interwoven, we'll say. Where do you think that plays? Is it something that this standards will be something that regulators might pick up? And how would that be adopted if they did?
Yeah, so the standard first has to clarify what the technology is. So we had to provide basic taxonomy, ontology, and definition, what it is, right? And then it's also important to create some reference architecture. By reference architecture, we mean that what are the building blocks that we can build a blockchain for the energy space. So that's kind of a way we are heading. So at the same time, understand what are the typical use case that can apply that, and how can we use that. So standard is gonna. There are 2 types of standard: the one that inform and guide, and the one that provide clauses like conditional clause, shall, may, and should. So we are looking at this kind of a standard. So we don't want to impose something, but we want to clarify and help the industry to understand there is a piece of technology we can use, and it's open source, and anyone can understand. We want to get the same ground, everybody in the same ground. So that's the idea.
Interesting. We're going to take a break here from our sponsors. We'll be right back to talk some more and get into how this connection to the energy industry and maybe some of the moving pieces you have there that we'll see coming down the pipe. Be right back.
Blockframe technology offers next-generation blockchain managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
All right, welcome back to New Cyber Frontier. On today, talking about global standards in blockchain and what's coming down for the future, how that's going to work, especially for transactive energy with Dr. Claudio Lima here. Dr. Lima, you before the break, we talked about bringing that standard, what that would come, what are you working on now? How's that applicable in the energy industry? We'll let you kind of roll with that.
Right. So there are a couple of use cases that we can use blockchain in the energy industry right now. So for instance, the renewable energy certificates. Today, you have RECs in a database, right, that can be changed, can be double counted. And that's the blockchain comes to help. So blockchain avoids this double spending idea. So it cannot generate two certificates, and then you have to retire the certificate, and you have to make sure that you have a timestamp validate that certification retirement. So that's one idea. So the other idea is settlement. So blockchain can help payments, settlements. So in most of the industry, we have this kind of issue. So blockchain helps a lot on the reconciliation and settlement of payments and transactions. And finally, I think cost reduction. So blockchain helps automate process and track and trace assets. And most likely, it can identify and validate any object or any device in the field. For instance, in a typical substation, you have multiple IEDs in intelligent energy devices or routers or transformers. So these are devices that has some electronics, and then therefore, if you want to make sure they have an origin, they have a ID that can be identified. So then you have to use blockchain to make sure that you validate all your critical asset in a typical environment. So, and blockchain can help track and trace all the environment who installed that device, what's the supply chain for that. So all this kind of thing, not only the hardware but also the software. So it's extremely important for the energy industry to embrace the idea of a blockchain that we call distributed ledger technology. So that's the technical term we use for this term, distributed ledger technology, DLT, is how we classify blockchain.
How closely related, all those different applications, do you see them as independent, or they all kind of come together at some point where, supply chain, the document levels, the hardware, the people that do maintenance, those were very different, treated very different in today's kind of landscape. Do you see that kind of comes together under blockchain, and where's that?
Yeah. So as I said, blockchain is not going to solve all your problems, but it's going to help creating this trustable layer for data, right? And data is everywhere. So data is generated by device, IoT, your vehicle, your generator, your diesel generator, your solar panel. So all this data coming from your house, for instance, they are not certified, right? So anyone can do whatever they want. So in order to certify the data, you have to tag the data where it has been generated at the point of origin, at the meter level, at a particular location, particular day of time. So that's how you started transacting blockchain-enabled events. So you will look at the transaction of your meter. It creates some consumption data. Then you tag with an ID and it runs in the blockchain. So anyone can verify that you consume that particular power at that particular time of the day. You can do that today, of course, with traditional centralized database, but anyone can go there and modify and replace and do whatever. So it's more trustable. It's good for auditing. It's good for regulation. So blockchain data is extremely helpful when you want to certify your data for insurance, for financial loans, for anything that is related to validating the credential of the originator.
Yeah. So and we hear a lot about that recently. Is the certificates or the different energy tokens, or what we call it, the green energy, like, hey, energy from solar onto the grid is worth more than energy from a coal plant because politically we want to go that way. So we're going to offer incentives. How do you, I mean, that seems to be a big focus with standardization and transactive energy. Is there maybe the biggest driver I've seen recently to get that done? What are you thinking about that as a key driver to making this happen?
Yeah, let's first define transactive energy, just to mention the important point. So transactive energy is a way for us as a householder who has solar panel, we have a surplus in electricity, so you can eventually can put that back to the grid, right? And someone, your neighbor who has who needs energy, so they can buy back. So it's kind of a local market enablement where you transact with your peers, could be neighbors, could be the next area, but basically, transactive energy is the way for you to sell and buy energy, and you have a marketplace. This marketplace is controlled or owned by utility, or maybe by the peers. So it depends on how the governance model is designed, right? So you have a strong regulated environment. You can still have peer-to-peer blockchain transactive energy system, and as well as completely decentralized environment. So by doing that, you enable your system to transact automatically via smart contract. A smart contract is an important component for the blockchain because it automates any business operation. So anything it does, you have in your system, it automatically put in a smart contract. It's going to automate transaction. So it avoids the human interference. So it's a very good tool. So have a smart contract, have a peer-enabled transactive system. Then the next step is to make sure that who originate the information has a credential validated by the blockchain. But then when you place your order to buy energy, then you go to this marketplace enabled system. Then you transact, you make money, you offer service, and that's the typical environment you're talking about. Yeah.
Definitely, it seems like I've heard talk about moving in that direction, but the first time I was engaged with somebody talking about transactive energy, and I want to kind of go back in time here, mid 2000s, we'll say, the Gridwise Architectural Council, and I think you were part of that at that point, came up with, here's the way, the theory, the vision for the future. There was a lot of dead years between then and now, and it seems like blockchain and the interest here is coming back to pick up on that. But why has it been stalled? So, why haven't we hit the ground running with this? Tell us about that.
I think it's more about regulation and acceptance. So PNNL from the DOE and the Gridwise architecture, so they've done a great job in defining and introducing transactive energy as it is, right? So it's lots of work has been done the past years. So, but now is the time where we can put this to work. In the blockchain, it's just one layer that fits on top of that, right? So it's not going to redefine transaction, it's just going to add another layer, a transformative layer that's going to validate any transaction that happen in the grid. So how the market is moving in this direction right now. So that blockchain is a new enabler to make transactive more acceptable, more easy to quantify, qualify, authenticate, and transact energy in a local market environment.
So you think that's why that there was such stagnation, is now we have the tool in blockchain to do some of the pieces that we're missing?
I think it's the momentum, not only because of blockchain only, it's because the momentum we are living in terms of virtual power plant, the aggregator market, like say the FRAC 222, and several other initiatives that's happened in the world that's going to facilitate this kind of plug and play your generator or your load to be sold by a market provider, right? And blockchain is going to just enable that. And you can just imagine this is going to be much more complex when you add the mobilities. So a typical electrical vehicle is a mobile generator, right? And you have to understand where it is at a particular time when you plug your vehicle back to the grid. So it's going to be a complex scenario, but that's our opportunity as well. So blockchain is an enablement of that opportunity. So transacting charging from mobile devices and vehicles is a big step towards this kind of grid decentralization with mobility.
Yeah. So what I heard you say is that early in the concept stage, the technology wasn't there, but the technology now being there a little bit with electric vehicles, with more efficient power generation. Now the legislative is the limiting factor, and they're starting to come on board too. And that's what I'm hearing, that I think having the standards to be able to say to the legislators, here's what we need to do, and here's how it can all come together, is even more so pushing that down the road.
Definitely, that's the idea. So standard is trying to catch up this game, right? So because industry startups are moving much faster than that, and regulator is kind of behind, but we're trying to come up with the same idea. But you're right. So the momentum for decentralization, the momentum for new service offer for the grid, like virtual power plant, is right for blockchain. And then you see lots of pilots worldwide. I think the only tricky part here is that to select which platform should we use, right? Yeah. So there are multiple options in the industry today, and then there are lots of consortiums. Everybody's trying to sell their solution. I would say there is no a single solution that fits all the needs. So you have to be careful with that. So when you do standardization, we are always trying to come up with some reference architecture that is good enough to accommodate all the vendors and all the innovation possible.
Yeah, and you have a plan for that. Go through your kind of plan for moving forward through this process.
Yeah, so from the now back to the transactive energy, I think we are moving forward. So I would say that maybe 80% or more of the application of the blockchain in the energy space is on trading and transactive. So transactive energy and energy trading takes most of the application in this field. The remaining ones are the one I mentioned, plus others like supply chain. That's why IEEE decided to create this initiative called Blockchain Transactive Energy Initiative BCT. So we put together a proposal almost 2 years ago to the board of directors, and it got approved. And we got a NIC proposal funding mechanism. That's how we are moving forward with this strategic project for the IEEE Blockchain Initiative.
Mm-hmm. And the roadmap I saw at 2021, the next year after, what are you looking at? Go through your timeline here.
Yeah, so the timeline for the BCT project is about to finish next year. So we have a 3 years funding. So we expect that by end of next year, we are going to transition not only the BCT, but the entire blockchain initiatives. We are going to transition to create or be absorbed by IEEE site. So we are going to move from a single initiative to be our official association from the IEEE. So that's the goal for next year. And the BCT is the same. The BCT, we have phases. We just finished the white paper. The position paper is released in our website. It has been a great work from the team. So almost 8 months working to come up with this vision paper from the BCT. So we are talking to utilities, regulator. We got good reception now because we are trying to clarify how we can use the blockchain in energy, particularly on the transactive energy side. And now the next phase that we are in now is road shows and demos. So we just finished our first release for a call for proposal. So IEEE is BCT project promoting demos. We have some funding capabilities to support the startups, utilities, government, whoever wants to present innovative ideas that can support this direction. So next year, we are going to open maybe 10 call for proposals for demonstration project, and that's part of the IEEE roadmap.
Okay. So how can, kind of in closing here, how can people get involved? What do you need help with? Where can we jump in?
That's a good point. So there is one more point I forgot to mention. So the BCT, we are also building the architecture framework. So we need help with that. We need help from utilities, regulators, whoever has interest and expertise to help. So we have IEEE.
We hope you have enjoyed this episode of New Cyber Frontier. Remember to get involved. Often we think that someone else will handle privacy and security in the virtual world, but you are the only one truly in command of your virtual fate. join our mailing list so we can keep you informed of breaking news and new releases. If you have an idea, if you have a question that you would like to hear answered, or if you want to get involved with our efforts, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors' links, as they are the ones that really make this show possible. I want to thank each of you for supporting the show, and we look forward to seeing you back for the next episode of New Cyber Frontier.